Hi, I'm Paul. We're doing Leetcode must-know interview questions. The challenge today is minimum number of arrows to burst balloons. Rating is medium. And here's the challenge. There are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points where points I equals x start and x end. I'm sorry, points I equals x start, x end. This is confusing. Denotes a balloon whose horizontal diameter stretches between x start and x end. You do not know the exact y coordinates of the balloons. As it turns out, that's not important because we are shooting the arrows vertically. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x. If x is between x start and x end, there is no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons in its path. Given the array points, return the minimum number of arrows that must be shot to burst all balloons. Okay. Let's see. 2, 3, 4. I'm just looking at the examples here. 1, 2, 2, 3. Okay, those overlap. Points, x start, x end. So those are ints. I guess the most interesting example is example 1. All right, let's take a quick look at this and then we'll code it. Okay, so what we're looking at here is the points array from example 1 sorted. They're sorted in order of the second element. Incidentally, they're sorted in order of the first element as well, but that's why we have the second array here. Ignore the second array for now, and we'll get back to it in a minute. But we're sorted in order of the second element, and what we're going to do is we're going to start with the first element, and we are going to shoot an arrow vertically. We are going to shoot it at point 6. And when we shoot that arrow, it's going to burst the first balloon. We're going to then look at the second balloon, and we're going to say, is the start of this balloon less than or equal to the last arrow that we shot at 6? And it is. So that arrow is also going to pop this balloon. So that's 1 arrow, 2 balloons. We then look at the first element of the next element, and we say, is that less than or equal to the last arrow that we shot? Well, the arrow that we shot was at 6. So no, this is not going to pop with that arrow. So we're going to have to shoot another arrow. And let's do this. Let's shoot it at 12. Okay, the second element in that interval. We go to the next interval. We look at the start. It's 10. Is 10 less than or equal to the last arrow that we shot at 12? It is. So it's going to pop that balloon. So that's 2 arrows. 2 arrows that we have to shoot. Now, here's the question of why we don't sort it in order of the first element. So let's say, and I changed the 1, 6 to a 5, 6, and I just sorted it in order of the first element. So we're going to shoot at 8. We're going to shoot at 8. It's going to go up and pop the first balloon. Then we look at the next element, the start, 5. Is that less than or equal to the last arrow that we shot? And it is. But it isn't going to pop this balloon because this balloon ends at 6. We shot at 8. All right, so that arrow is going to go completely to the right of this second balloon. So that's why we need to sort in order of the second element, because we're shooting at second elements and then we're comparing the start element of the next balloon to the last arrow that we shot. Okay, so that's an example of why sorting by the first element won't work. And then let's go ahead and see what the code might look like. Okay, so as I said, we need to sort the array. Let me scroll this back up a little bit. Yeah, so we'll get an array like this, unsorted, and we need to sort it. We need to sort it by the second element in each interval. So let's do this. Arrays dot sort. We're going to sort, what is it called? Points. And we're going to sort it. You could do this. We need a comparator function. We need a comparator here. You can do it with a lambda function. We've done it with a lambda function in the past. Here's another way to do it. We can say comparator dot comparing int. I need a little more space here to be able to see that. And scoot that over. Comparing int. Comparator, comparing int. Okay, let's give this a name. It could be anything. We'll call it interval. And we are sorting on interval. Interval at index 1. We also need a counter to count how many arrows we shoot. Initially, 0. We need the previous arrow position. Now, what are the constraints here? Negative, it's 2 to the 31st minus 1, negative 2. I mean, I think that all fits in an int. So, actually, let me show you what I'm looking at here. I'm looking at this. I don't want to just miss it by 1. And it turns out we need a long, but I think an int will work here. So let's say int previous position equals integer dot min value. All right, we are ready for the for loop. We can use an enhanced for loop for each interval in points. Let's see, do we want start, end? Yeah, let's say the start of the interval will be interval at index 0. And the end of the interval will be at index 1. Now, if the start is greater than the previous position, that's why we initialized it to the smallest value that we could initialize it to. Oh gosh, you know what? I wonder if that is going to hit. Well, we'll find out. If the start is greater than the previous position, then we missed this interval. And so what we're going to have to do is fire another arrow and set the previous position to the end of the interval. And is that all we need? So we're going to go through each interval. We're going to check for the start being greater than the previous position. If it's not, if it's less than or equal to the previous position that we shot from, then this balloon has already been popped and we don't have to do anything. So after the for loop, we can return count. All right. I can think of at least one reason why this might not work, but let's run it and see what happens. All right. Accepted. All right, good. Yeah, I didn't anticipate any problems with that, but let's try the submit. All right, submit. Wrong answer. Yeah, that's with like big numbers. All right, I was afraid of that. Well, let's try this then. Let's try long and long min value, because I think we might get a tie there as far as the largest number that we can fit in there. All right, let's submit it now. All right. Okay, good. 57 milliseconds. Huh. Well, not thrilled with that time. What could we have done differently here? I mean, we got to sort it. We got to do this. I don't know. Anyway, that is the solution. Sort by the end of each interval, and then go through the array comparing the start of the next interval to where did we last shoot an arrow from. And that should do it. Thanks for watching. Please feel free to like, subscribe, comment, and see you next time.